Hello, Assalamu alaikum. Welcome to this tutorial for Lab 1. This tutorial is supposed to be an add-on to your lab manual. Since you would have already gone to the MATLAB on-ramp course, this tutorial is there to go through a couple of examples, which is going to help you attempt those additional problems at the end of your handout. So the idea is to use all those commands, all the programming from MATLAB that you've learned through those tasks and actually consolidate them and use them in a real life example and in something more tangible, in a problem that is presented to you. For example, if a question is posed to you, a question like either of these, we're going to attempt both these questions. And then how can we program in MATLAB? How can we use the functions that we know to solve these problems or to figure out what's the answer? So that is what those additional problems are for. So we're just going to do a couple of those problems here to actually get you the hang of it. So you have a reference material as well, so that after going through this and the course that you've already gone through, you can attempt those problems. So let's start. We will be using MATLAB Online. As you know, you would have already made an account at MathWorks. So just go to MATLAB Online, and I'm using a live script here. Just made a new live script, saved it as Lab 1 tutorial. And the idea is that whatever I type, I can simply see the results right here, as you did in the course. So this is just going to help us visualize as we go. Right, so let's get to it. First, it asks, the question is to choose 5 numbers from 5 to 10 at random. And they're going to represent the radius of 5 circles. So let's just say I take R. Now we know that if we use random function and we generate 5 random numbers, we generate an array that is 1 by 5. Now you can see these are the numbers that are generated 1, 2, 3, 4, 5. Now the rand function generates the numbers between 0 and 1. However, we don't need the rand function. We don't need it between 0 and 1. We need to scale them and shift so that the numbers are between 5 and 10. It's mentioned here, we don't want them from 0 to 1. We want them from 5 to 10. So first, what are we going to do first? First, we're going to change from 0 to 1 to 5 to 0 to 5 by multiplying it by 5. So now as you see these numbers 4.8, 4.7 here, 2.4, 269, these numbers are between 0 to 5. Because first they were 0 to 1, so we multiplied by 5, now it's between 0 to 5. Now what else do we need to do to make it from 5 to 10? Well, we simply need to add 5. Now you see, here they are. 5.7, 7.108, 9.5. These are random numbers generated between 5 and 10, right? You could simply done this in one line as well. First, I generated the random number, I multiplied by 5 and I added 5. I could have also done same command in just one line. This is also going to give me random numbers between 5 and 10, as you can see here. So R2 and R3 are both random numbers between 5 and 10. I'll just use R3 for now. In fact, let's call it radius. Makes more sense because these are our radius. Now, what we need to do is find area. And as you all should know, the area is simply pi r square. Now, another careful point while we're taking the square, we want to square each element in the array. Hence, we're going to use the dot squaring operation, not just the square, the dot squaring, because then it's going to square each element rather than just take an entire array. That is going to be our area, and the circumference, let's call it circ, is simply 2 pi r. Now, since we know that pi is a scalar, 2 is also a scalar, we can simply multiply it by an array r. We don't have to use dot multiplication. We can if it's not going to create any sort of error if you want to be extra careful, but simply redundant, there is no need for it. So, as you can see, this is the radius, this is the area. Oh wait, my apologies, I used r here, I should be using radius. Now these are the areas, and this is the circumference corresponding to this R. For this R, this is the area, this is the circumference. For this R, this is the area, this is the circumference. Now, what is the task? We have to find the index and value of minimum circumference and index and value of maximum area. So now we are familiar with using the max function, and if the max function returns us the maximum value. However, if, as you would have seen in the course, if you save it in two variables, then it's going to return you the max value, which is going to be the max area, and it's also, we have to find the max area. So it's also going to give you the index as well. So max area index, and the max function simply does that. And we're going to do the same thing for the circumference. The min function works in the same way the max function does. Now let's see. Now these were the radii, and this is the area, this is the circumference. The maximum area, as you can tell from here as well, it's simply 301.5. This is the value of the maximum, and it's at index 1. So we know the programming is working perfectly fine. And what's the minimum circumference? Well, if you manually want to check, this 35.709, that's exactly what's stored in the minimum circumference, and it is at index 3. So this is how you do this first question. So if anyone wants you to generate, just perform any sort of analysis on circles randomly with radius between 5 and 10, and figure out if you, this is just 5 random numbers. What if you have 10,000 of them possible? So you can simply use these functions, and first you can always manipulate the random function in a way to generate the random numbers between some particular range that you want by scaling it and adding it appropriately. And then you can use the minimum and the maximum functions. That was for question 1. Let's move on to question 2. Right. First, let's clear the areas. You know, CLC means clearing up the area. That's a different section, so we don't have anything here. So now let A be the sum of all odd numbers from 500 to 600. So A is the sum of all odd numbers from 500 to 600. First, let me make a list or array of all odd numbers, and then I'm going to take the sum. So it's easy to visualize. All numbers between 500 to 600. Now the first number is 501. We know the first number between 500 to 600 that is odd is 501. And then we're going to keep on taking odd numbers, because odd numbers we know occur with an interval of 2, odd, even, odd, even. Hence, we can use this spacing and keep on going until we reach 600. Now notice I could also write 599 here, that's the last odd number. But if I also write 600, since after 599, if we add 2 more, we're going to go to 601, it should not be included in the A. So as we can see here, this is our array, 535, 37, 39, these are all odd numbers. And the last odd number is 599. Because the next, after 599, if we add 2, it's simply going to go to 601, but that is outside our range. So we could write 599 here or 600, it's all the same. And A is just the sum of these numbers. So it's simply sum of A, which is 27,500. Now, if anyone were to ask you sum of all odd numbers between 501 to 600, you can either go use those complicated analytical equations, analytical formulas, or start counting it manually, or you can simply use these 2 lines of programming. What's next? B, let B be the sum of all multiples of 7 between 100 and 200. Again, we'll first make an array of all multiples of 7 between 100 and 200. The first one is 105. And then multiples of 7, you know, occur after interval of 7. So we'll just keep on taking all multiples of 7. Again, don't need to calculate what's the last one. You can do that, but if I simply write 200, then any multiple of 7 before 200 is going to be included. And then afterwards, if you add 7 and it exceeds 200, it will simply not be written in the array. As you can see from here, 105, 112, and it keeps going to 196. exactly. And B was just the sum of these numbers. So B turns out to be 2,107. And what do we need to do? We need to find the difference. So let's say difference is A minus B. Difference is 25,393. Again, if someone posed you a simple question, what's the difference between sum of all odd numbers between 500 and 600 and sum of all multiples of 7 between 100 and 200, you can write this. This is for visualization. You can write both these in one single line. So 3 lines of code, that's all it takes. So the idea is you're familiar with maximum, minimum, indexing, the sum functions. Now we're just going to consolidate it together in one single problem and use that knowledge to solve that problem, tackle that problem. These were just 2 examples of such problems, and the rest are written in your lab manual handout at the end. So do try them, and best of luck for it. I hope this tutorial helps you. Use MATLAB online like we did. You can use live scripts if you want to keep on visualizing your results here, or you can use normal script as well. Totally up to you. Anyways, good luck.